Hi everyone, welcome back to ICS 111, Intro to Computer Science 1. In this video, we'll be looking at exception handling. By now, you may have experienced some kind of crash when running your program. For example, if your program asks the user to enter a number, but the user enters a word like banana, your program will crash. When the input is not the expected data type, the scanner will cause your program to crash. Note that this is just one type of crash. Your program may crash for a variety of reasons. Also, a program crashing is not the same as a compiler error. When you compile your program and get errors, it is likely due to some syntax error. That is not your program crashing. A program has to run in order for it to crash, hence the word crash. A program crashes during runtime, which is the step after compiling. When your program crashes, it is due to these things called exceptions. We will be taking a look at some common exceptions and learn how to handle them using try-catch so that your user does not experience crashes. So to start, what is an exception? An exception is an event that disrupts program execution. An event meaning something that happens. So an exception is something that happens that disrupts the run of a program. Exceptions may prevent a program from compiling, and those are called checked exceptions. Exceptions may cause your program to crash, and those are unchecked exceptions. So there are two types of exceptions here, checked and unchecked. The ones we will be dealing with for now are unchecked, the ones that cause your programs to crash. Later on in the semester, we will be working with and creating our own custom checked exceptions. When your program crashes, it is because of an exception. A program crashing is okay, and some people dedicate their careers to purposefully crashing programs, but make sure you learn from them. Test your code by crashing your program on purpose. Run your program and figure out where things can go wrong. For example, an assignment may have many example outputs, and that's the purpose of having multiple example outputs. It's not that I created separate programs for each output. It is the same program to demonstrate how your programs should behave given different kinds of input. You should be testing your programs using all of the examples shown to ensure your program is producing the expected output. The end user, which is not you, should not have to experience crashes. Testing a program is never a one and done deal. Your program may crash for a variety of reasons or just one specific reason. As a programmer, you will need to anticipate the possibility of exceptions happening when things can go wrong in your program. Even if you create very descriptive instructions and feedback to the user on how to use the program, they don't always read it and they don't always follow through. So we will need to use exception handling and anticipate those things happening. So let's take a look at some common exceptions and how to handle it. The first exception is called the arithmetic exception. The arithmetic exception happens when there is an error during any kind of arithmetic operation. Arithmetic operation meaning add, subtract, multiply, and divide. For instance, integer division by 0. Know that you cannot divide a number by 0, but if you were to do this in a Java program, int div0 equals integer 5 divided by integer 0, actually this line is syntactically correct. Syntactically correct meaning it will pass the compiler. As I mentioned previously, one of the jobs that the compiler does is type checking. So the compiler will see, oh, you're trying to do division. I will just make sure that there is a number on the left side of the division and on the right side of the division. 5 is a number and 0 is a number. So the compiler says, yes, that is valid Java syntax. But when you run the program, it will crash. Only at runtime will Java actually perform the division and then find out, hey, you can't do that. You can't take integer 5 and divide it by integer 0, so the arithmetic exception will happen. Now you might be thinking, oh, that's easy then. I just won't put a 0 as the divisor. Well, the input may come from some outside source, and you as the programmer do not control that source. And in this case, if you're getting input from the user, even if you have some very nice descriptive message to tell the user what to do, for example, please enter a non-zero integer, the user may still enter 0. And if your program takes that value and throws it into the computation, then the arithmetic exception will happen. Also, the result of some other arithmetic may result in a division by 0. For example, maybe the user does actually follow the directions. They don't actually type in 0, but maybe the combination of values that they enter results in a 0. So on this slide, I have some variables, input 1, input 2, and input 3. And let's say those values come from the user. So the user entered 15, 7, and 8. So none of those values is a 0. But take a look at the computation. The computation divides the subtraction of input 1 minus input 2 minus input 3. So even though the user did not enter any zeros specifically, the unique combination of values resulted in a 0. So when an exception happens, it will look like this. On the bottom in JGrasp, you'll see this message, exception in thread main, and then the exception, java.lang.arithmeticException. If you get this kind of message, exception in thread main, that is your program crashing. In order to address your program crashing, we will need to handle the exception. In order to do that, we will use try and catch. In Java, when an exception happens, the exception is thrown. That is the analogy that Java uses. Exceptions are thrown, and in order to handle it, we will catch it. Throw exceptions and catch them. So there's this thing called a try and a catch. So let's see what that looks like. Try catch is in reference to a block of code. So we have a try block and a catch block. The stuff in the try contains code that is called risky. The try block contains risky code. Risky meaning exception throwing code. If a line of code throws an exception, you will want to put that in the try block. You also want to put any code that depends on that risky code. After the try block, you have a catch block. The catch block is what you want to do when the exception happens, and you need to know the name of the exception and you need to declare a variable. When your program successfully catches an exception, if there is any code after the catch block, the program will continue execution. But if there's no code after the catch, then your program may just end on its own. So let's break this down, the try and the catch. So the try block contains risky code that will throw an exception, but it also may contain code that is dependent or related to that risky code. Immediately after a try block, there must be a catch block. So you cannot just have a standalone try, there must be a catch. You cannot have any executable code between the try and the catch. That will be a compiler error if you do that. Also note the curly brackets. So try is a reserved word. It should turn purple when you type it into JGrasp. So you say try, a space, and then opening and closing curly bracket, and then give yourself some working space between those curly brackets. Now the code inside the try is indented. Anytime you are entering code in between curly brackets, that will signify a new level of code. And remember, you can always use the CSD button in JGrasp to automatically indent the code for you. And it will do it with a 3-space indentation. Okay, so we have the try block that contains the risky code or the exception throwing code. After a try block, you have the catch block. The catch block contains code, what you want to do when the exception happens. Now you need to know the exception that you are trying to catch. The catch block itself is placed immediately after the try block. You cannot have any code between the try and the catch. And just like the try, any code inside the catch needs to be indented. So when the exception is thrown, what do you want the program to do? How do you want the program to handle it? When you create your catch block, you do need to know the exception that caused the program to crash. And that is why testing your program is so important. Java makes it somewhat easy because Java will tell you the specific exception that was thrown. So you create a program and you crash it on purpose. You read the messages that come up. So for example, this arithmetic exception. If the arithmetic exception happens or is thrown, then this is what it would look like. Exception in thread main, and then it says java.lang.arithmetic exception. And this is how you can tell which exception you need to catch. All Java-defined exceptions end with exception. Arithmetic exception, we will see the input mismatch exception very soon, but it's always something exception, something 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 exception. Those are Java-defined exceptions. Okay, so once you crash your program on purpose and you identify the exception that you need to catch, you will take the catch block syntax. So you have catch, and then in parentheses, you need to know the name of the exception and put a variable name. Both of those things are in parentheses, and then after the parentheses, you have an opening and closing curly bracket, just like the try. So take the syntax and replace the name of exception and exception variable. So I take the name of the exception as I saw it in the message, java.lang.arithmetic exception, a space, and then your variable name. So this first part, that is the name of the exception as I saw it in the message when the program crashed. And the second part, this is the exception variable name. The name is something we choose or something you come up with. It is how to reference the exception in the catch block. In ICS 111, the name isn't as important because we will be creating our own message. The exception variable itself contains more information about the crash. We are not actually going to be using the exception variable, but we do need to declare it as part of the catch block syntax. In this class, we are going to be creating our own custom messages to tell the user why the program crashed and how to correct the mistake. Because we need to declare a variable, but it's not used, I use a naming convention that takes the first letter of the exception name and the last letter of the exception name. So I use AE for arithmetic exception. You can follow that naming convention as well, or you can create a more meaningful name that reflects why the exception happened in your program. Now we have a catch block and it looks like this. Catch java.lang.arithmetic exception, a space, and then a variable name. And I just use AE. But if you recall, a certain package is automatically imported by default, and that is the lang package. So java.lang is already imported by default. So actually, we can shorten this a little bit, and we can say just arithmetic exception by itself. So we'll have catch arithmetic exception AE, and then in between the curly brackets is what we want the program to do if the arithmetic exception is thrown. What that looks like in our divide by zero example is this. We take that exception throwing line, so that line that will cause the arithmetic exception to happen, and put that in the try. And notice it is indented. Code inside the try and the catch is indented. And if the arithmetic exception happens, the execution will jump down to the catch block that catches the arithmetic exception. And what do I want to do? Well, I'll just tell the user an error message. Error, trying to divide by 0. So if I were to take this code and stick it in a program, compile and run, the message I'll get is error, trying to divide by 0. because the arithmetic exception is happening when Java actually tries to divide by 0. Alright, so this is just one exception, the arithmetic exception. It happens when there's some kind of error during arithmetic. What about when we ask the user for input? Let's take a look at input exceptions. Exceptions that are thrown when using the scanner. These occur when the user enters something in an incorrect type. So the scanner is expecting the input in one type, but receives input in another. Recall that when you use the scanner and tell it to go get input, you have to specify the type. You tell the scanner to go get input as an integer, you use the nextInt method. When you tell the scanner to go get input as a double or as a string, you will use a specific method to get input as that data type. But if that data does not fit in the specified type, you will get some kind of exception. When you're using the scanner, you will need to anticipate the types of errors the user can make. So let's see an example. Here's a snippet of a program that asks the user for their age and then spits it back out. So I create a scanner object, I create an integer variable to store that user's age, and then go ahead and ask the user for their age. So enter your age, and then I tell the scanner, go get the age as an integer. So I'll say reader.nextInt. So that method call tells the scanner to go get input from the keyboard as an integer and then store it in an integer variable input age. After that's done, I'll spit it right back out to the user. Your age is, and then I print out the variable. Now here, at this method call is where an exception can occur. When the scanner retrieves the input, the scanner is expecting the input to be an integer, but if the user does something like this, so enter your age, and then the user types in no, and then hits enter, the program will crash. You'll get some kind of message that looks very similar to this, exception in thread main, java.util.input mismatch exception. And when you see this message, exception in thread main, that is your program crashing. Now, when your program crashes, you might want to pause, take a breath, and think about the error calmly. Java tells you specifically the exception that was thrown. So you look at the error message calmly and see what that exception is. It says exception in thread main, java.util.input mismatch exception. So that is the exception that needs to be caught. You will catch java.util.input mismatch exception. Other than crashing your program on purpose, how can you determine the exceptions that will be thrown? Well, if you're using a method of a Java class that you can look up in the Java API, when you look at the full description of a method, there is a throws section. So on this slide, I'm showing you the full description of the nextInt method in the scanner class. On the bottom of the full description, there is a throws section, and it says throws, input mismatch exception, no such element exception, and illegal state exception. So those are the exceptions that can be thrown when using the nextInt method. So if you are curious what other exceptions that can be thrown, you can look at the Java API. Some of the exceptions will not apply to your program. So yes, you still need to purposefully crash your program to see which of those exceptions actually happen. In this class, we're not going to worry about no such element exception or illegal state exception. We are focusing on the input mismatch exception. What the error message also tells you is where the exception happened. So on the very last line of all that green text, so on the slide, it says at noaskmyage.main, and then in parentheses, noaskmyage.java:8. So that last part, noaskmyage.java, that's the file name, and then 8, that is the line number, where the exception was thrown. So this error message tells you two things. It tells you the name of the exception that was thrown, and where it happened. So what you'll do, go back into the code and then set up your try catch. Identify the risky code and also the code that is related to it. So I highlighted both the print instruction and the assignment. Even though the exception is thrown on the line with the next int method, I'll also include the print instruction because that is related to the next int. That's the prompt to the user. So I'll take these two lines for now and I'll put those in a try block. And then after the try block, I'll have my catch. I know the specific exception that I'm catching. It's java.util.inputMismatchException. And I'll use the naming convention with the first letter of input and the first letter of exception. So I'll have the IE there. What do I want to do when the exception is thrown? For now, I'll just output an error message. Error, integer not entered. So I take the risky code and I wrap it in a try. After the try, I have my catch. Okay, so if I take this code, recompile, and then run it, this is what the run will look like if the user types in no again. After they type in no, hit enter, then I'll get the message error, integer not entered. Okay, that's good. The fact that it prints error, integer not entered means that the catch block did execute, therefore the exception was handled. But take a look at that third line of output. It says your age is 0. And that's kind of weird. If there was something wrong with the age, I actually don't want to print out this message. But this also highlights a separate behavior. If your program successfully catches an exception, the program continues execution afterwards. So if there is code after the catch block, it will execute. So in this case, after the catch block executed, the code after the catch block also got executed. So that print with the your age is, that printed. But logically, if there was something wrong with the age, you wouldn't want to output this message. So what we're going to do is move that line also inside the try, because that line is actually dependent on the risky code. It's dependent on the program actually retrieving an integer. But if there is something wrong with the integer, we don't want to output this message. So we will put it inside the try, and it'll look like this. The your age is, that line will only execute if the program successfully retrieved an integer from the user. Because if there was something wrong with the input, the exception will occur at the next int method call. When the next int method throws the input mismatch exception on this line, the execution jumps to a matching catch block. So the next int method throws an input mismatch exception, then Java will look for a catch block that catches input mismatch exception. So it will jump down to the catch block. The remaining code in the try after that line is ignored. It does not execute. So if the exception happens, then the your age, that does not execute at all, because the point of execution jumps down to the catch and then executes the code in the catch block. In our class, the programs are relatively small. So if an exception does get thrown, typically we want nothing else to happen in the program. So we will have nothing after the catch block. Later on, I will show you how to forcefully terminate a program, but it is important to understand program flow before abruptly terminating the program. So with the print inside the try, now if the user does type in no, they will only get the output error, integer not entered, because that print instruction gets skipped because the point of execution jumps down to the catch block. Anything in the catch will execute, and once the catch is done, any code after the catch will execute. But in that example, there's nothing after the catch, so the program will terminate on its own. When you get used to handling certain exceptions, it will be second nature which exceptions you'll need to catch. And when you know, you can import them at the top. When you do so, you can reference the exception without the package hierarchy. So for example, at the top of the program, if I import the scanner and I know the input mismatch exception will happen, then I'll also import it there as well. So I'll have these two lines at the very top of my program. When I import java.util.input mismatch exception, I can just reference input mismatch exception inside the catch. And I can do that because I've already told Java at the very top of the program where input mismatch exception is. It is in the util package. Now, if you have seen some Java examples online, or maybe from a different programming instructor, you may have seen this: import java.util.*. So you may be tempted to do that. What this does, it essentially tells Java that you may use everything in the util package. In this class, I do not actually want you to do this. I want you to import specific classes because that signals what you will be using from that package. It adds a layer of readability and predictability in your code because you as a programmer can get an idea of what kinds of things will happen in the program. If you just import java.util.*, then who knows what it is that you'll be using from the util package. You could be using the scanner, you could be using the random class, you could be using an exception. You won't know until you actually take a deeper dive into the code. But if you list the specific things that you are using, then you can kind of get an idea of what the program is going to do. So as a rule of thumb for this class, import an entire package if you are using more than 5 classes from it. So scanner is a class, input mismatch exception, that is a class. Only do the asterisk if you'll be using more than 5 things from that package. Otherwise, import specific things. I will want to see import java.util.scanner, import java.util.input mismatch exception. So you may be tempted to just do the asterisk, but I want to see the specific imports. All right, so let's continue on. When you're using a scanner, you will be using the different next methods to get the input. So we've already looked at nextInt, so that retrieves input as an integer. That may throw in input mismatch exception if the input is not an integer. This is probably the most restrictive number method because it has to be an integer. If it's anything other than an integer, then the input mismatch exception will be thrown. For next double, where we retrieve input as a double, that also throws an input mismatch exception, but it throws it if the input is not a number. Okay, in general, if it's not a number. If the user types in something like a word, like banana, then the next double method will throw the input mismatch exception. But this method will not throw an exception if the input is an integer. Take a few seconds to think why that is. If you use the next double, why is it that the method can accept an integer? It is because the integer will get widened. An integer can be stored in a double. That will be a widening conversion, and widening conversions happen automatically. If you use the next line method, the next line method is used to retrieve a line of input as a string. Now, the input mismatch exception is not thrown when you use the next line. And that is because strings are characters. Characters can be numbers, letters, symbols, or the empty string. Anything in between double quotes is a string, but strings cannot be used for arithmetic. So if you think that you can just use the next line to get any kind of input, that is not correct thinking. If you are going to be using the input for arithmetic, then you use some kind of numeric method, nextInt or next double. although this method does not throw input mismatch exception, it does throw an exception. This is normally applicable when reading a file, which we will do later in the semester. So this no such element exception, that occurs when you use the next line method, but there's actually nothing there to read in. If you are getting input from the keyboard, this exception does not need to be handled. Lastly, if you use the next method of a scanner to retrieve a word of input as a string, a word of input meaning a bunch of characters up to a space or a new line. So if the user types a sentence and you use the next method, only the first word in that sentence will be retrieved. It's up to some kind of white space. So that's either a hard space or a new line character. Same deal as next line. The input mismatch exception is not thrown, but it still can throw an exception, the no such element exception. If you are getting input from the keyboard, then this exception does not need to be handled. It's typically when you are reading in a file. Overall, when you're getting input using the scanner, numerical input is pretty straightforward. You use next int to get an integer, and you use next double to get a number. But when you get input as a string can be anything: numbers, letters, symbols. String input cannot be controlled to be meaningful. So what do I mean by that? If your program asks the user to enter their name, but instead they enter a bunch of numbers or characters, that is considered to be correct from Java's perspective. The actual input has no meaning. You will need to do other things to ensure that the user typed in something meaningful. For example, you can check the length to make sure that the user actually typed in something. The user could have just hit enter, and therefore that's the empty string. You can trim. You can look up this method trim. It is a method of the string class. It removes white space from the beginning and ending of a string. Or you can also do regular expressions. Regular expressions are covered in the scripting class. This is how you would ensure that a string only contains letters. With all this talk of exceptions, there's one exception that I do not want you to use in this class, and I will address it directly, and that is the exception. In Java, there is an exception called exception. This exception can catch any exception that is thrown, but do not do this in this class. I only put it on the slide just to show you what that looks like. If you do look up examples online, or even if a tutor shows you catch exception, I do not want to see catch exception in your programs. So this is what it looks like: catch exception E. When you catch exception, that is like the master ball of all exceptions. Catching exception can hide potential bugs that you as the programmer do not know about. You would not know why your program crashed specifically. Even though you can handle it in a try catch, you wouldn't know why the program crashed. What you want to do is handle all known exceptions and address unknown exceptions as they come up. And those are what's called bugs. There are times when catching exception is warranted, but those reasons do not apply to this class. Okay, so to review, when your program crashes, it's because an exception was thrown. And in order to handle it, we will catch it using a try catch. So the first part is a try block. It should contain at least one risky statement. Any code that is related to or dependent on that risky line should also be included in the try. After the try, you'll have a catch. So the catch is, what do you want to do when the exception is thrown? Now, if more than one exception may occur, you may have multiple catch blocks, but still only one try block. So if you catch once, it'll be a try catch. If you catch twice, because maybe the code can crash for two reasons, then you will have try catch catch. And note that there cannot be any executable code between the try and catch. So after the closing curly bracket of a try, there needs to be a catch block. the catch block needs to start after the closing curly bracket of the try. Now, this last block is more of an FYI, and that is a finally block. We won't really be using the finally block in this class, but it is something that you should be aware of. The finally block is placed after all catch blocks. It is the last block that can execute. A finally block is typically used for what's called code cleanup. So things like resetting your variables, closing files if you're working with files, or even closing a scanner. You can close your scanner if you're done with it. This is an optional block, so you don't need to have it. And the finally block executes after the try exits or a catch exits. So this is what it looks like. So you still have the try catch, and then after the catch is the finally. So the flow is, if you have a try, catch, and finally, if no exception was thrown, then the try block executes. And since no exception was thrown, none of the catch blocks executes. So it'll go to the finally block and then execute the code in there. If an exception was thrown and caught successfully, then it'll go from the try to the catch and then to the finally. But there's actually a third option here. There's actually a third path, and that is if an exception was thrown and not caught. And this actually doesn't apply just for finally, but in general. Now, if an exception was thrown, but you do not have a matching catch, then your program will crash normally, as if you did not have a try catch. So you'll get the message exception in thread main, and then Java will tell you the exception that was thrown. And then you go ahead and you address it, you go back into the code, and you create a catch block for that exception. But if an exception was thrown and there's no matching catch block, then your program will crash as if it did not have a try catch. All right, so let's do an example. Let's go into JGrasp and use a try catch to handle some exceptions. For our example, what I want to do is create a program that asks the user to enter a position in a string and then output the letter at that position. So I'll show the user the message and then ask the user to enter a position, and we'll spit out the letter at that position. This program is going to be called output letter. So let's go ahead and make the program skeleton for output letter. Public class output letter, and then we'll get our curly brackets. Let's set up the main method. Public static void main string array args. Get our curly brackets and some working space. So once we have the program skeleton, let's go ahead and save it. Click save, and let's compile. Compile now, because if it doesn't compile now, it won't compile later. For the message that I want to show the user, it'll be one that we are intimately familiar with, and that is the gotta catch 'em all. So let's go ahead and make that tagline variable. String tagline equals gotta catch 'em all. So what I want to do is output this string and ask the user for a position or an index, get the character at that index, and then print it out. Since we'll be getting input from the user, I will need to get the scanner. So let's come to the top of the program and give ourselves some working space and then import the scanner. Import java.util.scanner. And let's go ahead and compile at this point. Make sure you import the scanner okay. So I compile and don't get any error messages. So that's good. And let's continue on and let's actually make the scanner. Scanner reader equals new scanner. And we're getting input from the keyboard. So system.in. I will need a variable that stores the user input. So since I'm asking the user for an index, I will use an integer variable, and I will call this variable input index, and I'll initialize it to 0. Now, when I know the program is asking the user for some input and I need to store it in a variable, I usually prefix my variable names with input. So if I say input index, the value of this variable, it's going to come from some outside source. And that is a naming convention that I like to use. If it's a variable that's used to store input from the user or from some external source, I usually prefix it with input. Okay, so I have a variable that will store the user input. Now the next variable that I'm going to make will be the letter or character that I'm getting from the string. So this will be like my output variable. I'm going to be using the substring in this. So the substring returns a string. So I'll create a string variable and I'll call it output letter, and I'll initialize it to the empty string. So the empty string is a good initial value for string variables. Okay, so I have a variable that will store the user input, and I have a variable that will store the output to the user. Okay, so we are declaring and initializing our variables. So let's go ahead and output a message to tell the user what this program does. I'll do a system out printf, and I'll tell the user to enter an index to output a letter from the string. And for the string, I'll use the format specifier S for string, and then a platform specific new line. And then the variable I list at the end is tagline. So this print will tell the user what to do. Enter an index to output a letter from the string, and then I'll output the string. So let's go ahead and compile and see what that looks like, and then run. Enter an index to output a letter from the string, gotta catch 'em all. Okay, so that looks good. Now let's go ahead and get the index from the user. So I will do a print, system out print, and I'll tell the user enter an index. And I'll have one space after my prompt symbol, so one space after the colon here, and then I'll go ahead and get that index from the user. I'll take my variable input index equals reader.nextInt. So I'll tell my scanner, go get input from the keyboard as an integer, and then I will store it in this variable input index. Okay, so once I have the index for what the user wants, now I want to get the thing at that index. So the program asks the user for an index. The user gives the program an index. Now we want to get the character at that index. So what would that look like? We will have the output letter variable equals, we'll take my tagline variable dot substring. So take a few seconds, pause the video. How would you use substring to get the letter or character at the given index? All right, so recall. Let's say I wanted to get this letter, the capital G. If I wanted to get just the capital G with substring, the indexes I will use will be 0, 1. If I wanted to get just this O, that will be 1, 2. If I wanted just this T, that will be 2, 3. So that T is at index 2, this O is at index 1, and this G is at index 0. So notice a pattern here. The first index is of the thing you want, and the second index we have to specify is just one more than that. So if the user tells us they want the letter at index 0, then we would do 0, 1. If the user wants the character at index 5, we will do 5, 6. So notice the pattern. It's just one more than what we actually want. So if the user tells us they want input index, then we will need to go from input index to input index plus 1. So it will look like this. Substring input index, comma, input index plus 1. And it'll look just like this. If the user does enter in 0, then this will be 0, 1. If the user enters 1, then this would be 1, 2. That plus 1 will give us that offset that we need to just get that one character. And this doesn't reassign the variable input index. Nowhere do you see an equals here. This addition is just the argument to the substring method. So it will allow us to offset it by 1. It doesn't change the value that is in input index because, again, you don't see any assignment happening here. We are just adding 1 as the argument to the substring method. All right, so once we got that, let's output it to the user. We'll output the index as well as the letter itself. So system out printf, the index is, and the index is some integer, and then we'll do a new line. We'll list the variable input index, and then we'll do a system out printf again, and let's output the letter. The letter is some string, and then we'll list the variable output letter. So we tell the user what this program does. We ask the user for some input. We get it, and then we use it in the substring method to get that one letter the user wants, and then we'll spit it all back out to the user. So what is that index and what is that letter? So we'll compile. It compiles okay, so let's run. So we'll enter an index. So if I enter 0 and then hit enter, so the index is 0 and the letter is capital G. Now there are some assumptions I'm making. I'm assuming that the user knows what a string is and that it is 0-based indexing, but that's beside the point for this exercise. For now, I just want to make sure that it is working. So if I run it again, and let's say I do index 7, hit enter. And index 7, that is the letter A, and I can double check that. If I just come up to the top and then count, 0, 1, 2, 3, 4, 5, 6, 7, that will give me the A in catch. Okay, so it looks like this program is working okay. It is able to get the index and output the letter at that specific index. So once we have the program working, we are assuming that the user will enter in valid indexes. Now is the time we're going to try and crash our program and see what kind of exceptions will happen. So let's go ahead and run. And let's see. The first thing we can do, well, let's just hit enter. If we just hit enter, then it looks like it's just a blank line. And if we just hit enter a few more times, then nothing really happens. So let's go ahead and enter an integer and then hit enter. Okay, so that really didn't do anything. So let's go ahead and run again. This time, let's add in a word. So let's do banana. I'll hit enter. And okay, so this is my program crashing. The scanner expected an integer, but instead it got this word banana. And here I get the message, exception in thread main, java.util.input mismatch exception. All right, so this is the exception that I will need to handle, java.util.input mismatch exception. And notice down here, it tells me output letter.java:18. And that 18, that is the line number. And actually, if you click on this line, it will take you to that line in the source code, and it'll even highlight it. So if you click down here, then the line will highlight. And so this tells me that this is where the exception occurred. So I know the exception that got thrown, and I know where it was thrown. It was thrown here on this line, line 18. So what I'll do is actually I'll take both of these lines. I'll take both of these lines and let's wrap them in a try catch. So here's how I'm going to do that. Even though the exception is not thrown on this line with the prompt, it is related to this line, the next int. I'll group them and I'll put both of them in the try block. So here's how I'm going to wrap these two lines in a try. I'll place my cursor right above where I want the try to start. I'll hit enter to give myself some working space. I'll start the try, space, and then opening curly bracket, and then where I want the try to end is here, right below the method call for next int. So these two lines are now wrapped in a try. Putting code in a try, that is nested, so you will need to indent. Anytime you put code in between curly brackets, you'll need to indent the code. Luckily, JGrasp has the CSD button. So if I click on the CSD button, it will indent the code and show me all the logical blocks. But I'll just turn it off because I just want it to indent my code. Now, if I try to compile at this point, then I'll get this message, error, try without catch. And this was just from compiling. So this is not my program crashing. This is a syntax error. So it tells me try without a catch. So immediately after a try, you need to have a catch here. So I'll say catch, and then in parentheses, the name of the exception, which was java.util.input mismatch exception, a space, and then a variable name. I'll just do IE for input mismatch exception, close the parentheses, and then we have opening and closing curly brackets. So inside the curly brackets, what do I want to do if this exception is thrown? Well, I will want to output an error message. So let's do a system out. I'll do a println this time, and I'll just say error. Please enter an integer. Just like that. So now that I've completed the catch, I can try and recompile, and it compiles okay. So immediately after the try, there has to be a catch block. So I'll say catch, the name of the exception, a variable name, and then what do I want to do when the exception is thrown? I'll just output an error message. Okay, so I've compiled. Let's try and run it and see what that looks like. So enter an index. Let's do banana again because that's what caused the error last time. So if I do banana and then hit enter, then, okay, so it says error, please enter an integer. And then the index is 0, the letter is capital G. And okay, so that's not really what I want. The reason why I'm getting these two lines is because the program is continuing execution after the catch. And my initial value for input index is a 0. So that's why I'm getting the G at the end. The initial value for this variable is a 0. So I'm getting the letter at 0, 1 in the substring. But if there's something wrong with the index, I actually don't want any of these things to output. So I don't want to get the substring, and I don't want to output the index or the letter. So what we can do is we'll take these lines and I'm going to move them inside the try. So I'll cut it and then I will place it in the try and paste it like this. Now all I did was a cut and paste. When I pasted, now the indentation's all funky. But again, that's okay because if I do the CSD button, turn it on and then turn it off, it will automatically indent my code. So what happens now is if the exception happens on this line, if the user types in banana, then the input mismatch exception is thrown, and all this stuff after in the remaining of the try, that gets skipped. It doesn't execute. So the point of execution, if the exception is thrown, it's going to skip from this line and come down here to a matching catch block and then run the code in the catch. And then since there is no code after the catch, the program will just end on its own. So let's see what that looks like. If I recompile's okay, and then run. Since I made some changes, you still want to make sure that the program works normally. So if I do some valid indexes, 3, hit enter, I get the T. Okay, so that's still working. If I do 17, hit enter, I get the L. Okay, so the program is still working given valid indexes. Now let's try the banana. Banana. So I'll run again and then type in banana, hit enter. And here I go. Okay, it says error. Please enter an integer. And then that's it. So nothing else happened. So these lines of code did not execute because the exception was thrown on this line and then jumps down here to the catch. The catch executes. And then since there is nothing after the catch, the program just ends. And that is the expected behavior that I want. Okay, so this is looking good. Now let's see what happens if I run the program again, and let's try to crash it again. So we tried it where the input is not an integer. Even if I do some decimal number like this, 1.0, hit enter, then I still get the error message, please enter an integer. This counts for all non-integer input. Now if I run again, what else can go wrong? So you might want to pause the video at this point and try and think of what else can go wrong. What else can go wrong is if the user does type in an integer, but that integer is an invalid index. So maybe the user doesn't really understand what an index is, so they'll just put any kind number inside. So if I do like 100, 100 is an integer, so it should be accepted by next int. So let's see what happens if I hit enter. Enter, and oh, there, my program crashes. It crashes at a different point. It crashes here on line 21. So if I scroll up, and then here Java tells me, exception in thread main, java.lang.string index out of bounds exception. And that's kind of a mouthful, but string index out of bounds exception. And you can see it's in the lang package. So actually I can just say string index out of bounds exception. I don't have to include the package hierarchy. It gives me some message. So begin 100, end 101, but the length of the string is 18. So string index out of bounds exception, that sounds exactly what is happening. So the substring is trying to get a letter at index 100, but there's no such index as 100. The length of the string is only up to 18, so we get this exception. And we get this exception at line 21. So we know where the exception happened, and we know the name of the exception. Now you may be tempted to wrap this line in a try catch. Try like this, then you'll have a try in a try. But actually this is not needed. So I'm gonna not do that. I will not have an inner try. Instead, I can have another catch, okay? Another catch after my first catch. Anything in the try may crash for a variety of reasons, and this is a situation. So we can add another catch after the first one instead of doing another inner try catch. And plus, if there is something wrong with this substring, we do not want these lines to execute. So it means that there was something wrong with actually getting a letter out of the string. If there was something wrong with getting a letter out of the string, then we don't want these two lines to execute anyway. So we want the execution to jump somewhere else and then output the error message. So here's what I'm going to do. After this catch, I will add another one. And this one is for the string index out of bounds exception. And I'll call this one SE. So after my catch that I just made, I also want to compile. I want to compile to make sure it is valid Java syntax. Notice I didn't have to say java.lang.string index out of bounds exception because the lang package is automatically imported. So I don't need to say java.lang. So what do I want to do? If the index is invalid, then I want to output a message. Let's do system out print line, and let's do error. Enter an integer between 0 and 17 without decimal. Even though I said enter an integer, they may still try to enter something like 1.0. So I'll specify and say without decimal here. Error, enter an integer between 0 and 17 without decimal. Okay, so that looks good. Let's try and recompile. It recompiles okay. And let's run. Enter an index. So you still want to make sure that the program runs in the normal case. So if I do 0, hit enter, I get that G. If I run again, and let's do 17, hit enter, I get that L. If I do banana, hit enter, please enter an integer. Okay, that looks good. Run again, and let's do 100, hit enter, and there I get my second catch, error, enter an integer between 0 and 17 without decimal. So the fact that I am getting this message in the output means that the exception is being caught in this specific string index out of bounds exception. So notice from before, even though I had a try catch, I wasn't catching this exception specifically. The program still crashed like normal. If there is no matching catch, then your program will crash as if there is no try catch. So this looks good. I think I've accounted for how the program can crash when getting input from the user. So if the user enters a non-integer, and if the user enters an integer but it is an invalid index, I'll get that string out of bounds exception. Now for this java.util, actually what I'll do is I'll delete it, and let's get some practice importing the exception. So up at the top, I'll do import java.util.input mismatch exception, and then compile, and then it compiles okay. Now, if you forget the import, let's see what happens. If you forget the import, let's comment that out, and then compile. Then I'll get a compiler error. It says error, cannot find symbol, and then you can see the caret here. It's pointing at the input mismatch exception. So Java doesn't actually know what this input mismatch exception is until you tell it where it is. So either you would do java.util.input mismatch exception, or you import it here at the top. So I'll uncomment that and then recompile, and then it compiles okay. All right, so that's going to conclude our example with try catch. You set up a program that works initially, and then you try to break it. Try and crash it on purpose, see what kinds of exceptions happen, and then set up your try catch. Now, when you are commenting a try catch, take a look at the posted example on Laulima and see how I am commenting the try and the catch. Even though you cannot have executable code between a try and a catch, you can still add comments because comments are ignored by Java. Catch specific exceptions, do not catch exception E. If you have any questions, please let me know.